So welcome to the third in our series of presentations on Taicaan Technologies' surface analysis tool, BEX. You can see the window in front of you. We have a pyramid structure, a structured surface with 10 pyramids along one axis, 10 on the other, and we discussed the key actions and techniques for viewing this data in the previous presentation. In this presentation, I very much want to focus on the color scale here. In the last presentation, we highlighted the probability graph showing the histogram of heights, and we added the statistical lines. And rather than run through all of these in turn, I'm just going to pick up on some key ones and show you some key features. Now, the first one is actually, it is listed here because actually if I click on the color scale, you can see a number of options appear to the left. Taicaan, spring, summer, etc. But rather than use that, I prefer to use the same option, which is in the top left here. You can see an icon, which is an aperture, a coloured aperture, and beside that it has the word jet. And actually that's the colour scale that we've been using. That's the colour scale that runs from the red to the blue. If I just click on that, you can see I have the same drop-down menu as I had on the right-hand side of the screen. But the nice thing here is I can scroll through these so we can see what each one looks like. Because this is highlighted in blue, it's active, so I can now use the mouse wheel just to rotate through the color scale. So this is the Taicaan color scale, which we've used for many years. This one runs from white through to black, running through red, blue, and then to black. Let's switch through these. So the next one is spring. It's a very pinky colors. Summer, lots of green. Autumn, yellow colours. Winter, blue colours. Jet, that's the one we have been using. Cool colours here, cold colours. Hot colours, and then cold to hot. Cold to hot is very similar to jet. It's running from red to blue, but it's very much centred on green, much more green in the centre here. So this image appears to be much more green. And then finally, black and white's a monochrome. So just switching through these. And you can choose whichever of these suits you best. I'm going to continue with jet for the time being. Let's go back to jet, and here it is. So if I just click on the image space, that's deactivated. I'm now back into the jet color scale is the main one. So coming back to where I started on the right-hand side here, if I just right-click again, we have a number of options, and all of these options are techniques by which we can adjust the color scale. First of all, very simply, if I only want to see data that sits within, shall we say, plus or minus one standard deviation of the mean, if I click the first one, it's then adjusted the color scale accordingly. So now the data is very much centered around the mean. It's running to plus one standard deviation, minus one standard deviation, and if you look at the data on the left, you can see the color scale is now dominated by the peaks of the pyramids are white. In other words, they are outside of the plus or minus one standard deviation range, and you can see some black features here in the wells at the bottom of the pyramids, also outside of that range. This hasn't changed the data. This is purely the way in which the data is represented in the color space. So just going back, if I click back on full range, I come back to where we started. Now, not easily apparent, but very important item. I think you can just see this in the top here, where I'm pointing with the crosshair. There's a blue line. If I click that, I can drag the line down, and now I can actually choose the maximum height representation of the surface just by adjusting this. So if I just choose here, and I do the same on the bottom, again you can't see this, but there's a yellow bar here which I can scroll up, and you can see I'm just adjusting this. I'm going to remove most of the base here and just concentrate on sides of the pyramids, and now you can see how the image has changed according to that selection. Again, just going back to this and click back to the full range takes us back. Again, lots of options. You can use different values of standard deviation. You can set the maximum and set the minimum. You can do the custom range, which is what we were doing by using the sliders. And then finally, you're able to fixate the scale. So let's go I only want my data to be plus or minus 2 standard deviations. Click that. Right click here. I'm now going to fixate that. What that means is the data has now been permanently changed. And that's noticed here by referring to the top of the screen here. You can see we had our data set, the plane had been removed, and now we've rescaled the data. And now if you look at the data, you can see that the peaks of the pyramids have disappeared. They're no longer there because we've actually removed them permanently from the data set. So lots of black areas where the peaks of the pyramids have been removed. Well, I didn't mean to do that. Let's go back to the original. So let's click on the original by using the ring right at the top of the screen. So that while that's loading, it's got a big data set, so let's let that. And here's the original. So now we have the rescaled data and the original data as shown here. Right, what I want to do now, final part of this particular talk, is to look at, again on the color scale, something very useful. It's this button here, so right towards the bottom of this, contours. I'm just going to click that, and you can see straight away what this has done. It has drawn contours on the view, and the scale to which that is being done is by looking at this slider here. This is actually drawing 5 contours per millimeter. It's quite a large sample here, and you can see the effect of that on the pyramid structure. Now this is actually particularly important when we use the top-down view, and you'll just see this now. So let me just click finally to the top-down view, and now you can see what it's done to the top-down view. It's a very nice way of representing the top-down view, which doesn't have the lighting effect of the 3D views, but you can now see the 3D effect by using the contours.